Hello everyone, this is Melody Rondeau and I'm going to be working us through our lesson on sequences of transformations. Our learning intention, I'm learning how to apply a sequence of transformations to a figure. Our success criteria, this first one we've actually seen before. I can explain why a transformation or sequence of transformations is rigid or non-rigid. So a quick review of that. Remember, rigid means we only change the position or location of a figure. We don't change size or shape. Non-rigid is the one where you can change anything. Then our next success criteria, I can describe a sequence of transformations that will carry one figure onto another by giving a verbal description, that means using words, or by writing a rule. And that will be in coordinate notation. Our last one, I can predict the effect of a rigid motion on a given figure. Before we go forward, I do want to draw attention to a vocabulary word here. We have the word sequences, and in this case, what we are talking about with sequences, we have the idea of one thing happening after another. And so this is what we mean by sequences in this case, one thing happening after another. So one after another, we're going to do a transformation, and then another one back to back. So we'll have like two transformations in one problem. It'll be delightful. All right, sorry, I just want to rewrite this really quickly. One after another. Cool, let's go forward. Here we go. All right, so we're going to translate triangle ABC. The first transformation, you can grab your red with me. Oh, if you want to make sure you follow the colors, I am using red and green. You might want to pause it and go grab those if you haven't already. All right, so my first transformation I'm going to do is right here. It is right 4 and up 4. This would be a translation. It's my first transformation. And if I was going to write that as a rule, that would be xy turns into, so I start with xy. If I'm going right 4, then with my x, I'm going to say x, and then right would be adding 4. And then for the up 4, that would be a number that goes with my y. Since it's up, that would also be adding. So I would say plus 4. So that's the rule I could use to do this. We'll talk about it more in a minute. Then I'm going to switch colors to green. And this says that I'm going to rotate 90 degrees counterclockwise. And that rule is going to be xy turns into, I believe it's negative yx, but I'm going to double check that for us. Okay, perfect. So yes, negative yx for that one. Okay, and then we'll answer the question at the end, is the sequence of transformations rigid or non-rigid? All right, to get us started, let's go and find those order pairs. So I'm going to start with A, which is located at, looks like negative 1, 2. And then I have B, which is located at, looks like negative 3, 4. And then C, which is located at negative 2, 5. All right, so once we have the order pairs, we're going to go ahead and apply the rules or do the transformation. So for the translation for that first one, because it gives us a description, right 4 and up 4, we can either use the rule and go through and plug in the values, add the 4, or we can just go to our figure and take each point. So I'm going to start with A and move it right 1, 2, 3, 4, and then up 4, 1, 2, 3, 4. So my A prime would be here. And then I do the same thing with the other ordered pairs. Before I do that, though, I am going to write down what my new value is for A prime. So that was right 4, 1, 2, 3, 4, up 1, 2, 3, 4. I am now at 3, 6. So 3, 6. Then I'm going to do it with my B. So right 4, 1, 2, 3, 4, up 1, 2, 3, 4. Looks like I'm at B prime. I'm going to put my B on the other side here. And looks like I'm at 1, 8. So I'm going to go ahead and put that down. All right, and then we'll switch over to C. Last one, right 1, 2, 3, 4, up 1, 2, 3, 4. So there is my C prime. I don't know why it did that. Don't mind me. There we go. And that was C prime. There we go. Okay. So let's go ahead and connect the dots as best you can. Just try to draw a nice little triangle here. And when I do that, here we go. That is my first transformation. I just accomplished the first one. Ooh, I forgot to write my C prime ordered paired. Let's see. C prime is at, looks like 2, 9. Okay, so there's the first one. The second transformation, we're going to build on top of that one. So when I go to do the second one, my rotate 90 degrees counterclockwise, the X and Y that I use for the rule are coming from my red ordered pairs from that first image. So this one, when I go to create the next one, I'm actually creating what we call a double prime, because now this is my second copy or my second image. So a double prime is going to take, like the rule says, I'm going to do a negative, then the Y value, and then my X, which is 3. So I'm going to go put that on the graph. A double prime is at -6 and then 3. That is my A prime, double prime, excuse me. So I get two apostrophes there. And then I'm going to do my B double prime. And I do the same thing. So negative Y, so negative and Y, and then my X. So -8, 1. There's B double prime. And then finally, my last one, C double prime, again, negative, the Y value, and then the X. C double prime is at -9, 2, which will put me right there. There's C double prime, and then, of course, connect the dots. And then we're going to see if we can answer that question. Is the sequence of transformations rigid or non-rigid? Did we change the size and or shape, or did we just move the location? For this one, it looks like we just moved location. So this one is actually rigid motion. Because again, we didn't change the size or shape of that little triangle. It just moved a bunch. All right, let's try the next one. Draw the image of the triangle after the given sequence of transformation. So this time, last time our transformation was given to us in words and I numbered them. I gave us the rule to kind of help follow, but we were given our transformation in words. This time we're given it as a rule. And so it's going to work the same way, but now I have a rule to apply. So I'm going to start with my ordered pairs for my triangle here. So I'm going to start with A, which is located at, looks like 0, -2. Then I have B, which is located at, let's see, -2, -4. So I don't know why I gave myself so much space, but let's see if we can do this. Okay. -2, -4. And then C located at -4, -4. There we go. Okay. So to get us started, we're going to go to that first ordered pair, or I'm sorry, the first part of the rule, that first arrow, and that I'm going to do in red. It's my first transformation. And notice the only thing we're asked to do here is to use a 3 with the X. Remember, that is multiplication. So I'm going to basically take my X value and multiply it by 3. So to get A prime, I'm going to do 3 times 0, which would be 0, and then I get -2. The Y stays the same. So I'm going to go ahead and put that on my graph, 0, -2. So right where the A is, I also have A prime. Then I'm going to do B prime, and again, I'm going to do 3 times the X. So I'm going to come over here to my X value, which is -2, and I'm going to multiply it by 3. I get -6. And then -4, the Y value stays the same. So on my graph, I'm going to go -6, negative 4. And there is my b prime. And then finally, c prime, same basic thing. I'm going to do multiply by 3 for the x. So 3 times negative 4 is negative 12. And then the y value stays the same at negative 4. All right, so let's put that on our graph. Negative 12, negative 4, way over here. There is my c prime. And yes, we get the joy of connecting the dots. So I'm going to connect the pieces of my triangle here. Let's see, a prime to b prime, and this one's the fun one. Something like that. All right, so there's my first transformation, my first part of my sequence. So there's the first one. Let's go over to the second one. So my second one has something a little bit different to it. It has some 1/2s in there. And so you may recall these say do 1/2 times x and then negative 1/2 times y. So when we multiply by 1/2, that's the same as saying basically divide by 2 or cut it in half. So a lot of these we can do in our heads, but even if you're not sure, I will show the math at the bottom to help us out. So starting with the first one, this says I'm going to take the 1/2 times the x. So I'm going to take x and multiply it by half or cut it in half. Well, half of 0, because my x is 0, is, whoopsie, let me write a double prime here. There we go. A double prime. So 1/2 times 0 is 0. Then I have negative 1/2 for the y times negative 2. This is going to give me a positive 1. But again, I'm going to show us down here at the bottom where I have a little bit more space. So I'm going to do my a information here. So this is saying I'm going to do 1/2 times my x, which was 0. And then I'm going to do negative 1/2 times my y, which was negative 2. In order to multiply that this one here, the fraction by the whole number, I am going to need to put this over 1. So this is my whole overall problem here that I'm working on. Okay, so there's my ordered pair. So I'm going to do a little bit of math here. So 1/2 times 0, this part is just 0. There's the 0. And then here, when I multiply straight across, negative 1 times, so straight across, negative 1 times negative 2 is a 2. And then 2 times 1 is 2. So my final answer, when I simplify all of that, is going to be 0, 1, because 2 divided by 2 is 1. So hopefully that helps in terms of the math, what we're doing. So I'm going to go 0, 1, and I'm going to put a double prime on my graph. Then I'm going to go to the next one. So I have b double prime. Again, I'm going to follow the rule which says basically take half of it. So half of negative 6 would be negative 3. And negative half of negative 4 is actually going to be a positive 2, because the negative makes a positive, and then half of 4 is the 2. All right, and then I will show the math down here though, just in case. And so the math down here would be I'm doing 1/2 times my negative 6, which I'm going to put over 1. That's the x part. And then I'm doing negative 1/2 times the y, which is negative 4, which I will put over 1. So I have some nice fractions there. When I multiply straight across, 1 times negative 6 for the x part here. So again, going to the x, 1 times negative 6 is negative 6. 2 times 1 is 2. So just multiplying straight across, I get that. And then for my y's, negative 1 times negative 4 is a positive 4, and then 2 times 1 is 2. All right, and then when I simplify that, negative 6 divided by 2 is negative 3, 4 divided by 2 is 2. So that is the math behind what we were doing if you're not comfortable with just taking the half. Okay, so let's put it on our graph. We have negative 3 and then 2, negative 3 up 2. There is my b prime. Did I get that right? Negative 3, 2. Okay, yeah, b prime. Double prime, excuse me, double prime. There we go. All right, and then finally c double prime. One more time, we're going to do half of negative 12 would be negative 6. And then a negative half of negative 4 is going to be a positive 2. And we actually already did that calculation, so we should be okay there for that one. But I will go ahead and show us the math just in case. So I have 1/2 times negative 6. And I'm going to put it over 1 to make it a fraction. My other one is negative 1/2 times 4. And I'm going to put it over 1 to make it a fraction. When I simplify that, I get 1 times negative, oh, I put 6. I apologize. Whoopsie, sorry. This is not negative 6. The x value back up in C, the red x value was negative 12. That will make a difference in our answer. Okay, let's try it again. 1 times negative 12 is negative 12. 2 times 1 is 2. And then I do the y values. Negative 1 times, and somehow I missed my negative 4. Sorry, the y value is negative 4. Negative times a negative there makes a positive 4. And then 2 times 1 is 2. If I simplify that, I get negative 12 divided by 2 is negative 6. 4 divided by 2 is 2. So again, matching it up, making sure we understand the steps there. Okay, so let's put that on our graph. Negative 6 and then 2. All right, so this is going to be my C prime. I'm going to really quickly switch where I put my B prime because that is going to actually cause me a little bit of trouble when I try to connect. Okay, and then let's connect the dots. Here we go. And of course, the question we're dying to answer is this rigid or non-rigid? Did we keep the same size and shape and only change location? Or did we change other things? This one, we changed multiple things. We changed the size, the shape, the location. We changed lots of things. So this one would actually be non-rigid. All right, then we're going to shift gears a little bit onto the next example. This one is going to ask us to describe the sequence of transformations that will accomplish this. So we're going to do it by using words and then also by writing a rule. So first look at this particular transformation is actually to look at the directions. It says trapezoid WZXY is mapped to trapezoid DGFE. The order of those letters is super important. And we'll see that specifically in the next unit. They're telling us which letters match up with which. So in other words, the W has to match up with the D, and then the Z has to match with the G, and so on and so forth. So when we look at this, if you just look at the picture, it looks a lot like a 180 rotation. But here is the problem. If I try to do this as a 180 rotation and I start with point W and I go, okay, yeah, I just rotated point W 1, 2 quadrants, I end up with that W here, which W is supposed to match up with D, not G. So I see that I have a problem. It's kind of flipped in a way that is not quite right. So it's not a rotation. It means we're doing something a little bit different here. So there's a couple ways we can go about this. I'm going to suggest that if it's not a rotation, that we actually flip over our picture. So I'm going to actually do a reflection. And I'm writing that as if it's the answer, but I want to pause there for a minute. So I'm going to do a reflection. I'm going to do it quickly across the x-axis. So I'm going to flip W is 2 above the x-axis, so I'm going to flip it 2 below. This would be W prime. And then Z is 2 above. I flip it 2 below. There's Z prime. And then my X below by 2, I'm going to flip it up by 2 boxes. I should be saying boxes because the scaling is a little weird here. That's okay. X prime. And then Z is 2 below. So Y is 2 below, so I'm going to flip it to 2 above. So we should have something that looks like that. And I'm going to actually get rid of these really quick so we can see it in red. And then if I connect the dots, so this was an x-axis reflection. I flipped it across the x-axis, so it kind of flips over like this. Then if I use this new figure, I feel like we can more easily figure out how to get to the other situation. So let's take a look. Sorry, let me redraw this really quickly. Okay. All right, so once again, my goal is to get them to match up. So I'm trying to get W to match up with D, which means I want this point to match with this point. So I don't want to flip it over. I could try and flip it across the y-axis, but that's going to make W actually go 1, 2, 3 boxes away. 1, 2, 3 boxes away from the y-axis. It's not going to line up right. So what I can do though is I can actually just move it. We can do a translation. And so I'm going to grab my green and count how many boxes over did this move. So this moved 1, 2, 3, 4, 5. If I just slide everything over 5 boxes, then it looks like I'll be okay. So for this, that 5 boxes, be really careful because the scaling on the graph is actually each box represents 2. So this is actually going right 10. And it's 10 units because the way the graph is scaled. So watch out. Okay, so here's what we're going to do for writing our rule. We're going to start in words. This was I did a reflect across. So this is part A, sorry. Reflect across the x-axis. And then the second thing I did was translate, write 10 units. So that would be writing my transformation in words, or what our our success criteria has for the verbal description part. That's what we mean is writing it in words. The second part of our question here is to write the rule. So basically I need to figure out what the rule is for each one of these and put it into a progression. So I'm going to say XY turns into, and then I'm going to go look up my rules for an x-axis reflection. So across the x-axis, the x should be staying the same and the y flips to a negative. So it should be x comma negative y. I believe, hold on, just looking really quick. X negative y, yes, okay. So that, and you guys can look up the rules, that would be going to the x-axis reflection rule. But then I'm going to tag onto it what I did in terms of the translation. So remember, a translation is always going to deal, it's going to have x and y. So for my x, this is going to tell me going right or left. Since I went right 10 units, going to the right is plus, and then I do 10. For the y, I didn't move up or down with the y. So if you want to put it, you would just put y. Or if you wanted to, you could put in plus 0 to show that you didn't go up or down, you just stayed. So that is a way you could do that one. Or again, you could just leave it as y. And that answers example 3. Last one, predict the result of applying the sequence of transformations to the given figure. For this one, I'm going to remind us before we jump in about our quadrants. So we have quadrant 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. All right, so as we go through the list, I'm going to start with my regular writing utensil. And I'm going to go triangle LMN, which they give me, is translated left 2 units and up 3. So I do want to draw our attention to this word predict. So we're not actually drawing the sequence of transformations. We're trying to figure out where does our picture end up. And that's our prediction, is where we think it's going to end. So for the left 2 units and up 3. I'm just going to quickly look at like a point like M on my triangle. If I go left 2 and up 1, 2, 3. Point M, that's where my M prime would be. Where's my triangle? It's going to be somewhere in this vicinity, right? So it's going to be right about there. Here's my M prime. And so it's going to stay in quadrant 2. So this is my first transformation. So after transformation 1, it's going to stay in quadrant 2. So I moved a little bit, but I didn't really change location very much. Then I'm going to go to the next one. So let's switch to red. And this one says we're going to reflect across the y-axis. This is transformation 2. And so I'm going to take a look at where I kind of drew that circle is where we left off. If I flip across the y-axis, that means it's going to be over here like this. And that's where my new triangle will be now in quadrant 1. So I'm going to say flip, because a reflection is a flip. Flip to quadrant 1. And then let's see what our last transformation is. I'm going to switch to green. The last one then reflected across the x-axis. So this is our third transformation. I'm going to take where I left off over here in quadrant 1, and now I'm flipping across the x-axis, which means I'm going to end up flipping to quadrant 4 somewhere in this vicinity. So I'm going to say flip to quadrant 4. And so my final answer for my prediction, predict the result of applying the transformations, is that my figure is going to end in quadrant 4. And with that, that does finish our notes. Take a look at those success criteria. Go ahead and mark them off if you understand them, feel like you got it. If you still have questions, go ahead and circle it, and then check in with Google Classroom for your assignment. All right, we'll see you later. Bye.